Good morning, good evening, and hello everyone. My name is Payal Tandon. I'm one of the co-founders of GMAT, and I will be your host today in this webinar in which we're going to talk about error log for algebra. How is it that you can create error log as you're practicing your questions in algebra? So let's just make sure that all of you can hear me loud and clear. Can you please press yes if I'm audible, clearly audible? All right. Hi, Stephen, and hi, Shakil. I'm doing good. Thank you for asking. I hope all of you are geared up for solving some algebra questions today and creating an error log. All right, so let's get right into it. Agenda, same as what we've been working on since the last 3 sessions: SC error log, CR error log, number properties error log, and today we are talking about algebra error log. And you'll see that the basic principles behind all these error logs remains exactly the same. The basic principle is that you solve questions using the right process, and then you review the solutions and what I call as strategic review of the solutions, using detailed solutions, and then based on your review of the solutions and based on how you interacted with the question, you make appropriate entries in the error log. Okay, so today we are talking about algebra questions, but again, whatever we do here, as I said, the basic principle remains the same. So you can apply the same principles across the board for all subsections of quant, as well as verbal. Now, I want to make sure that all of you have the right foundation. And for that, we have free video lessons in the GMAT free trial to help you get started with algebra. So linear inequalities in two variables, quadratic inequalities, absolute equations, and absolute inequalities. So definitely, if you haven't as yet gone through this content, definitely go through this content so that you get your foundations right. Now, you don't have to go through this content in order to follow along what we'll be doing in this session, but definitely after the session, go through this content. Now, personalized study plan, very, very important. So if you are not sure as to where you're at, or if you're just starting your preparation, definitely take the free Sigma X mock test. That's the only test in the industry that gives you your subsectional abilities. Even the ESR, even your official mocks don't give you your subsectional abilities, okay? Then based on the results that you get from the Sigma X mock test, you should definitely create your personalized study plan. If you're not as yet an GMAT student, then definitely click here to schedule your consultation with one of our GMAT strategy experts so that they can help you create your personalized study plan. If you are an GMAT student, then you have access to this amazingly beautifully created AI-based study plan here so that you can create your own study plan. Now, if you want to get started with some other sections, intense correction, critical reasoning, number properties, RC, definitely we have content for that as well. Overall, just log into your free trial and you should be able to get access to all of this free content. Okay. Now, Shakil is asking, I'm writing GRE. Is it possible to use this strategy for GRE as well? Absolutely. The quant level for GRE is a little bit lower as compared to for GMAT, but the concepts tested are almost similar. I won't say exactly the same. There may be certain concepts that are tested on the GMAT but are not tested on the GRE. The approach for solving questions is exactly the same. I teach that same approach to my daughter who's in 7th grade. So again, it's the same basic approach to solve any kind of quant question. Okay, so yes, definitely it is applicable. All right, so we're going to do the same drill. There are going to be 7 questions in this session. I hope to finish all the 7 questions. If not, I'll give you the PDF so that you can take a look at the remaining questions, which we are not able to finish because we are always under that time constraint. We need to finish the session within a certain time duration. All right, and then once we solve a question, we are going to be looking at the error log and we're going to make the error log entry, okay? So let's get going with it. But first, let me just hear from you. What is your current comfort level with algebra before we go right into solving questions? How do you rate your comfort level in algebra? Okay, Ashwini says it's weak. Okay, let's hear from some more people, and that's okay. You're at the right place because you'll see what kind of focus, where do you need to focus in order to get to the right level in algebra. Okay, so it's absolutely fine. Stefan is saying medium. Yash 7 out of 10. Vinay good. Shakil weak. All right. So we have a good mix of people in this session. I have 26 people right now. All right, so let's get right into it. Now, what I'm going to do is I'm going to give you the question, and then I'm going to give you. So as soon as you have the response, just put your answer choice in the chat. All right, and then we'll go right into it. So here's question number 1. Now, all of these questions are 700 level questions. Question number 1 is from OG Advanced, and here is your question. And obviously, the answer choices are A, B, C, D, and E. And all of us are familiar with data sufficiency questions. That's why I haven't put in all the answer choices here. Okay. All right. So let's get going here. I'm going to mute myself, and good luck. Go ahead. All right, so I have a few responses here, not very many. So let's write down. Let's change the pen here. Okay. A, B, C, D, E. And we have 1, then, okay. Let's get some more responses here. I know some of you are not able to solve it. Preetham, another one for C. Okay. And then, yeah, all right. So I'll now solve the question. Now, if you think about it, what's been asked in this question? What's been provided to us is that sum of three numbers is positive. That's what is given to us, that sum of three numbers is positive. Now, do we know anything about whether these numbers are integers, whether these numbers are positive numbers, whether or what? Nothing. We don't know any of that stuff, right? So essentially what we have been given is that sum of three numbers is positive. Now these numbers can be negative numbers or positive numbers, but we need to know, we don't know as to what the magnitude of these numbers is. All we know is that the magnitude of these numbers and the signs are such that their sum is positive. And what we need to figure out is z greater than 1? That's what we need to find. Okay. Now we need a definitive answer. Whether z is greater than 1 or z is not greater than 1, we need a definitive answer, right? As long as we can get a definitive answer, whatever that answer may be, it doesn't matter, right? But we need to have a definite answer, and that is what we have to find out from the statements. Now let's take up statement number 1. Okay. Okay, so we take up statement 1. What is statement 1 saying? Z is greater than x plus y plus 1, right? Now, just make some observations here. What you have been given, and you always have to work with the given information, and that's why it's very important to absorb that given information. The given information is in terms of sum of three numbers, right? Now, over here, you have two of those three numbers. The third number is on the other side. Now, you have information that x plus y plus z is greater than 0. Now, how can you use that information in this inequality? What if you add z on both sides? Okay, if you do that, what are you going to get? You're going to get 2z is greater than x plus y plus z plus 1, right? Because if I add same number on both sides of the inequality, nothing changes. The inequality doesn't change. Now, what do I know? Over here, I have 2z, and I think I'm at the right place. Why? Because I needed to find the value of z. So I have z cornered in one place. Now, over here, x plus y plus z, what do I know about it? I know that this is greater than 0, right? It's some number greater than 0. 1 is a positive number, and I'm adding something to this number, which is already greater than 0, which means overall 2z is some number greater than 1, right? For sure. Because again, x plus y plus z could be a very small positive number, 0.2, 0.3. I don't know what it is. But I know for sure that this number, because it's greater than 0, which means that if added to 1, it would be greater than 1. So which means that 2z is greater than 1, right? Now, what does this mean? Z is greater than 1 by 2. So I know for sure, I can say for sure that z is greater than 1 by 2, but I cannot say for sure whether z is greater than 1 or not, which means that this statement is not sufficient. Which means that choice A or choice D cannot be my answers, which means that two of you who selected choices A and D, you made a mistake here. Okay. Now, if the question were, is Z positive? Then statement 1 would have been sufficient. But right now, the question is very specific, is Z greater than 1? Okay, so let's move on to the next statement now, statement 2. Now, what is statement 2 telling me? X plus y plus 1 is less than 0. Now, again, our strategy for statement 2 will be slightly different. Why would it be different? Because over here, again, what I really need to figure out is that I need to find the value of z, right? Whether z is greater than 1 or not. What I've been given is x plus y plus 1 is less than 0. So what if I write this down as x plus y is less than minus 1, right? Which means that what would be my x plus y, which means, again, I'm trying to figure out its relationship with 1. Where does x plus y lie in terms of the number 1? Because ultimately, that is what I have to compare z against, right? So what if I write this down as x plus y is less than minus 1, and then I manipulate it a little bit. x plus y, I multiply by -1 on both sides. And whenever you multiply by -1 on both sides or by a negative number on both sides, the sign of the inequality changes. So here I'm applying the concept of sign of the inequality. So for those of you who are not clear about how this sign changed here, this is a concept that I've applied. Okay, so now what I have is that minus x plus y is greater than 1. Okay, that's what I have, which means that let's say this, okay, so let's just leave it at this. Now what I also know from the question statement is x plus y plus z is greater than 0. Okay, now what if I write this down in terms of, I have x plus y, negative of x plus y. Let me do the same thing over here. I have x plus y over here. I'm actually manipulating because again, there are three numbers that I'm working with: 1, z, and x plus y. Right? So that's what I'm trying to figure out. Okay, can I get some definitive answers on a number line with regards to these numbers? So what I get over here is x plus y is greater than minus z. Now I need, now I'm going to multiply both sides by -1 so that I get the same term here. The term that I have over here, the same term I'm getting over here. Okay, now I have a relationship. Let's assume that this entity minus x plus y, which is same as this entity, is nothing but a number a. I'm just assuming that, just for the sake of ease, just for the ease of processing. Okay, so this is some number a. Now I go on to my number line. Okay, I have 1 as a number, right? 1 is something that I know. Okay, now a is greater than 1, which means a is somewhere over here. Okay, and z is greater than a, which means that z will be somewhere further away from a, right? Which means that overall z is greater than 1. Okay, so that basically tells me the answer, that gives me the answer for the question statement, which means that B is the correct answer over here. Okay, so now tell me what is it that you were not able to do? Now tell me, where did you falter in this question? All I'm doing over here is, if you think about it, for this statement, statement number 2, what am I doing? And let's write that down over here. For statement number 2, over here, I'm applying my visualization skills. Okay. This is a concept. This is a concept that you should know in terms of how the inequalities work when you multiply both sides of the inequality with a negative number. But as such, other than that concept, the skill that I really need over here is I need to sit back and just realize, okay, what is it that I need to do for this particular question? Okay, so over here, so I'm making some observations. Ultimately, what I need is I need a strategy to figure out the relationship between 1, z, and some other number, right? For that, you need to visualize, right? Which is what I'm doing over here. I'm just making certain observations. And again, you need to learn how to do that, okay? It's not anything about that you are not able to solve algebra questions. It's just that the same visualization skill is applicable across the board in number properties, word problems as well, right? So you literally have to sit down and visualize the information, okay? Now, next, what you're doing is over here, you are drawing the inference. Okay, over here you're taking up this information over here and this information over here, and you're drawing inference. So again, you need to be comfortable looking at these variables and making inferences. That's why you need to spend a lot of time on the question statement just to understand what is it that it's asking me to do. Okay, now what were the skills for statement number 1? Again, the same thing. We had to visualize here. Okay, now again, this is one of those questions, beautiful questions. Why? Because the information in the question statement is the same, but the kind of processing that you do for statement 1 is different from the kind of processing that you do for statement 2, and that really gives you that understanding of how many different ways I can visualize information, and how my visualization needs to be based on the information that's given to me, right? Over here we added z. Over here we simply considered one x plus y and z as three different entities over here, right? Over here, because it was given in terms of I have two inequalities, both in terms of x plus y plus z. I'm just trying to manipulate them and try to get the value of z. Okay, so again, visualization. And then over here, we had to draw an inference that, okay, z is greater than half, but which means that it's not, I don't know for sure whether it's greater than 1 or not. Okay, so really speaking, the skills that we apply over here are, let's come back over here. It's really the inference skills and the visualization skills. Okay, now I see that only one of you was able to solve this question correctly. So most likely why you faltered over here was because of visualization. You weren't able to visualize. Okay, so that's the skill that you need to build. Okay, all right, so now we're going to move on to our next question. Let's solve question number 2. There you go ahead. All right, let's get some more responses here. I have 2 for A. Okay, what else? Guys, I do have a hard stop at 9 o'clock today. I cannot really go beyond that time. So I am going to rush so that I can go through the solutions with you. Okay, so I did give you about 2 minutes to solve this question. So I think I'm going to cap it at 2 minutes. All right. Okay, so I have 3 responses for choice A. All right. So how was this question? I hope this question was not as difficult as the previous one. But again, this is also an official official guide advanced question, so it is a 700 level question. Now, okay, I have another one for A. Good, good. All right. Now I'm going to go through the solution, and I want to make sure that all of you solve this question using the right approach. And instead of working it out over here, I already have the solution here, so let me just walk you through this, because most of you are selecting the correct answer. So I'm going to walk you through the solution, and I want to make sure that you also solve the question in similar manner. Okay. Now I need to find the value of x, right? Now, what do? I have statement 1 over here. X raised to the power 4 plus x squared plus 1 is equal to 1 over the same term. Now, there are two ways of approaching this. And again, there may be more than two ways, but two ways that I could think of. One is I just look at this and I draw certain inferences. And what do I see over here? This is a number. This is the same number, okay? Which means that the number is same as its reciprocal. Now, there are only two numbers that are same as the reciprocal, right? 1 and -1, which means that x4, x to the power 4 plus x to the power 2 plus 1 is equal to 1 or -1. Oh, sorry, or over here, -1, okay? You can arrive at this either by drawing this inference, or you can do it algebraically as well. That is, you bring this over here, square equals 1, then you do all the processing over here. When you take the square root, it's very important that you take both the signs, +1 and -1. That's very important. So again, you need to consider all the cases. Okay, some of you may falter, may just take the positive square root, and that's not correct. May just consider the positive square root, and that's not correct. Okay, so that is one step. And I want to know, did anyone falter at this step? Did anyone not consider both +1 and -1 over here? So write that down in the chat box while I continue. Okay. Now, once you have +1 over here, you carry on with your solution. What you get over here is x squared into x squared plus 1 is equal to 0, which means that x squared is equal to 0, or x squared plus 1 is equal to 0, which is not possible at all, which means that over here you're getting for sure that x squared is equal to 0, right? So you have the value of x squared. Now let's consider this other case wherein this value was -1. Now, if this value is -1, what am I getting? I'm getting x squared product of two numbers as -2. And what are these two numbers? This is for sure a positive number. This is for sure a positive number as well, because square of a number, you add 1 to it, it would be positive, which means that this equation is not at all possible. Okay, thus the only possibility over here is x squared is equal to 0. Therefore, you have the value of x as 0. Okay, so statement 1 is sufficient, which means choices A or D could be correct answers. Now over here, this thing is relatively straightforward. X cubed plus x squared is equal to 0. This is what you get. Now this could be the case, or x is equal to -1. Again, not sufficient. Choice A is the correct answer. So did all of you solve the question in this manner, or is the principle that you applied similar to what we just talked about over here? So let's hear that, and then we'll also look at the error log over here. Again, the thing over here was inference and considering all cases. By all cases, I mean considering the square root as both positive and negative. Inference, again, you have to draw that inference. Okay, so most of you did well over here. Again, based on the responses that I have, I do have two of you who've said choices B as the correct answer. Again, I hope you can identify your mistake here. Okay. All right. So now let's go back to question over here, question number 3. Let's go ahead and solve it. All right, I don't see any responses yet. All right. So this seems to be a difficult question because it's been more than 2 minutes and I don't see even a single response yet. So what I'm going to do is I'm going to solve this question. If you think about it, this is all the only concept that you know that you need to know for this question is the factorial concept. What is a factorial of a number? Factorial of a number n is nothing but n into n minus 1 factorial, or you can write it n into n minus 1 into n minus 2 factorial, and so on and so forth, right? So that's the only concept that you need to know, okay? Now, I see that in terms of the responses, A, B, C, D, and E, one, Chetan is saying, I feel A as well. Chetan, you have to be firm. It's A or it's not A, right? So you have to be very firm with. And in quant, there is no gray area at all. In fact, in any of the GMAT questions, there aren't any gray areas, barring a few things. Okay. All right. So now let's take a look at statement 1. What I know is n is greater than 4. And n is an integer. Okay, so those are the two things that I know about n, and I need to find out the value of n. So I take up statement 1. Okay, now how do I solve this? There's a lot of factorials listed over here. So as long as I know how to process factorials, this is a very straightforward question. This is a question in which you only require the knowledge of factorial and how is it that you simplify. Okay, so I think a number of you are already putting A as the correct answer, and A is indeed a correct answer. So what I'm going to do is, in the interest of time, I'm going to show you the simplification, because over here, the only two things that are important are the concept of factorial, as I said, and the simplification scale. So this is how it needs to be done. So I'm not going to go through the solution here. Again, I want to do more questions rather than, just, again, the solution for this is relatively straightforward. So I'll share the PDF with you, go through the solution on your own and make sure that you don't falter. Over here, again, just to highlight, you get you get a definite value of n, and over here you get an equation which is true for all values of n. N plus 1 is equal to n plus 1. This equation is not telling me anything, right? N can be any number. So that's why statement 2 is not sufficient. So this is an inference that you have to draw over here, okay? So, but this is a difficult question. This is an official guide advanced, which means it is a 700 level question. And again, people who don't know the concept of factorial, they may get scared looking at this question. Okay, and plus you have to be persistent over here. There's a lot of simplification that is required. So again, just trust yourself and go ahead with it. All right. Okay. In terms of, again, the error log over here, this is, as I said, just the simplification, and you guys were able to do well over here. This is the concept over here of factorials, okay? Now, again, it's very important that when you are reviewing the solutions, you know, as you're reviewing the solution, what part of the solution did you not do correctly, okay? So that you can make that entry in your error log. For those of you who weren't able to select choice A as the correct answer, most likely you made a mistake with simplification. So that's what needs to go in your error log against this question, as well as factorials. Do you know the concept of factorial? Okay, those two entries are absolutely required in your error log. All right, now let's go to question number 4. But before I go into question number 4, I want to get a pulse of the class. How is it going for you? Are you gaining something from this from this exercise? We've solved 3 questions. We've looked at the error log for those 3 questions. So just want to hear something from you all. How is it going for you? The last question was hard. The last question required a lot of simplification, and that's the thing with quant questions. Once you know the concept, once you know how you're going to approach it, you just have to persevere through it. That's about it. All right. Okay. You guys are not that chatty today. All right. Let's go into question number 4. Yogesh is asking, can you tell something about error log in GMAT Club? No, I can't. Error log, in my opinion, needs to be something. Again, I haven't looked at the error log there. I'll be very frank. Again, the error log that I usually tell my students to utilize is something that's based on the process skills and concept skills both. So you need to be aware of what all process skills exist. And that's why I've been doing these sessions, so that you guys get aware, you guys get familiarized with those process skills. Okay, Rajal, thank you. All right, here you go. Go ahead and solve this question. Okay, I see 2 responses. Both are for C, and I gave you upwards of 2 minutes to solve this question. So I'm going to go into the solution here, because I do have, 2 more questions after this, or 3 more questions after this. So, all right, if S is the sum of first n positive integers, what is the value of n? Okay, now S is given as sum of first n positive integers. Now this is the only concept that you need to know over here, which is that S is equal to sum of first n integers is nothing but n into n plus 1 divided by 2. This is the concept that you needed to know in order to even get started with it. Okay, so if you weren't sure about this concept, then you would not be able to solve this question. Then you would be stuck here. Okay, so that's a conceptual knowledge. So if you were not able to solve this question, you need to ask whether this is whether you didn't know the concept, or whether you didn't know how to approach it further. Now let's carry further over here. Statement number 1, what is that telling me? Statement number 1 is saying that S is less than 20, which means that n into n plus 1 divided by 2 is less than 20. Now I process it further. Essentially what it's saying is n into n plus 1 is less than 40. Now I need to sit back and I need to just make an observation over here, not just continue to write down information, right? n into n plus 1 is less than 40. What does that mean? N, so this is really, so basically product of two consecutive numbers is less than 40. That's what it's telling me. Okay, product of two consecutive numbers, two consecutive integers is less than 40. That's what it's telling me. Now I think about 40, that as a number. 40 is equal to what? So I just start to 40. Is it possible to get 40 as a so let's start off with, let's say 6 times 7. That is equal to 42, right? So clearly this is not an applicable thing. And again, what do I need to find out? I need to find out the value of n, right? Now I go further down. 5 into 6 is equal to 30. Absolutely. So 5 is definitely one of the possible values of n. Then I go further down. 4 into 5 is equal to 20. Definitely 4 is also one of the numbers here. 3 into, so all I'm doing is I'm just, because again these numbers are small, so I can actually assume certain, so I can actually look at within this constraint what are the possible values of n. Okay, so that's what I'm doing over here. And again, I'm showing all the working out over here, but you would automatically realize that, okay, it's a positive number, so the least number possible will be 1, and n into n plus 1. So this definitely belongs in this particular, this definitely fits the bill over here, which means that the possible values of n over here are 1, 2, 3, 4, 5. It could be any of these values, which means that statement A1 is not sufficient, which means A and D are out. Okay. Now I do the same drill for statement 2. Statement 2 is a little bit more complicated. Okay. Why do I say that? Because it's a little bit, numbers are a little bit bigger. And again, I do the exact same processing for that. S squared is greater than 220, which means, so I apply my formula over here, n into n plus 1 divided by 2 whole square is greater than 220. So you do all of the processing here. You do stuff till this point, right? That's the simplification that you have to do. You have to do all that processing. Now, this is where you have to draw the inference. Okay, you again observe certain stuff. What does it say? N into n plus 1, product of two numbers, is greater than the square root of 880. Now here is where you have to do some estimation. Estimation is what you need to do. Okay, you think about it, and again, such estimation is not complicated, right? You have to, 880 is a very familiar number in terms of square. Why? Because 30 square is 900. So you know that, okay, 880 is pretty close to 900, which means that n into n plus 1 is definitely greater than 29. Okay, that is the inference that you have to draw over here. Okay, this is the inference that you have to draw over here, and then you consider the similar cases in a similar manner that we did earlier, and you figure out, okay, here the product is greater than 29, which means that you need to have a lower limit of n into n plus 1, and the upper limit will be infinity there, right? So that's what you're trying to figure out. What is the lower limit? Okay, so that's the inference that you are drawing over here. Okay, the lower limit over here is definitely 5. Okay, why? Because 4 into 5 is 20, which means that this doesn't belong in this particular range, right? So what you get is n is any number greater than or equal to 5, which means statement 2 is not sufficient, which means that yeah, C or E could be the correct answer. Now, when you combine both, what you get is n is equal to 5, which means C is the correct answer. Okay. Now, in terms of your process skills over here, the main process, again, this is the concept. So if you don't know the concept, you will not be able to proceed further. Then simplification needs to be done, and then the inference needs to be done. Okay. Simplification, you have, again, for simplification, you just have to follow through with it. Inference, you have to sit back and you have to understand, what does n into n plus 1 less than or greater than some number imply? Product of two numbers is less than or greater than. What does that imply? Okay, so that's the inference that you have to draw. So again, if you think about it, apart from the concepts, right? If you know the concepts, beyond that, it's really your comfort level with making observations, your comfort level with just processing information. Those are the process skills that you need to understand, right? So for those of you who knew the formula of of the sum of first n integers, but still faltered, you need to figure out what is it that you were not able to do, and then you need to work on building those process skills. And that's what you'll be able to do once you take a look at once you start interacting with the GMAT course. Okay. All right. So now let's go back to question number 5. All right, this is an interesting question. So go ahead and solve it. And I'm guessing, given the time, this would be the last question that we'll be able to do in this session. Okay, so let's go ahead. 2 minutes, go ahead and solve it. All right. So I have 2 responses, 3 responses, all for D. Okay, now I want to, before I go into the solution of this, I want to understand people who are responding, they are selecting the correct answer in this session. That's what I'm observing. For those of you who are not responding, who are not putting your answers, are you stuck? Are you just confused how to go about doing it? What is it? I want to understand that, because I see a difference in your response, in the manner in which you're putting in your responses amongst these different sessions. So I want to understand a little bit more as to why is it that people who are not answering questions, are you just stuck? That's why you're not able to solve it. That's why you're not putting in your answers. Okay, I'm getting some trickling responses here. All right, responses trickling in here. All right, so how many of the integers, okay, so is 5 included? Raphael is asking. Okay, we'll see. How many of the integers, that satisfy this inequality, or what is the inequality, this thing, are less than 5? Raphael, if it's saying less than 5, it means that 5 is not included. Okay, so 5 is not included. So really what I need to know is how many of these how many values of x that satisfy this inequality are less than 5. Okay, x is less than 5 for this particular question. Okay, all right, now how do I go about doing this? The first thing I have to do is put my pen down and just observe it. Okay, x plus 2 into x plus 3 divided by x minus 2 is greater than or equal to 0. Now we are used to solving linear inequalities, we're used to solving quadratic inequalities, but this doesn't fall in either of those two categories, right? So I need to bring it in a form that I can approach, right? Now, can I just do this? Can I say x plus 2 into x plus 3 is greater than or equal to 0 by taking this on the other side, x minus 2, multiplying 0 by x minus 2? Can I do this? Yes or no? Is this correct? Yes or no? Is this correct? Yes or no? All right, this is clearly this is not correct at all. Why? Because I don't know, and thank you, Abhishek, I don't know whether x minus 2 is positive or negative, right? And with inequalities, we know that if you multiply both sides of inequality with a negative number, then the sign of the inequality changes, right? So that's why you cannot do this. So this is absolutely wrong. Now, what else can I do? Can I multiply both sides by x minus 2 whole square? Absolutely, yes. Why? And why would that help me? If I multiply both sides by x minus 2 whole square, okay, but why can I do that? Because it's a positive number. If I multiply both sides of the inequality with a positive number, the sign of the inequality doesn't change. Now, when I do that, what I end up getting is x minus 2 into x plus 2 into x plus 3 is greater than or equal to 0, because what's happening is when I've multiplied both sides of the inequality by x minus 2 whole square, one of these terms gets cancelled out, and then yeah, okay. Now, Raphael, x minus 2 whole square is always positive, right? That's why I can multiply both sides of the inequality with x minus 2 whole square. Now, when I get this, beyond this, it's the process of solving quadratic inequalities. And I understand that this is not a quadratic inequality because the highest power of x is 3, but you can actually apply the same process that you use to solve a quadratic inequality over here as well. And what do we do there? And if you are a little bit rusty with that, I would highly recommend that you go through the quadratic inequalities concept file that is available to you in the free trial. So definitely look at that, okay? So over here, what I do is I get the roots. The first step to do is, after factorization, this is the factorized form, I find out the roots of x, which is plus 2, minus 2, and minus 3. These are the roots of x, okay? Now, I plot them on the number line, okay? Plus 2, minus 2, minus 3. Now, these are my roots, right? Which means that these are the ranges, possible ranges. This is range A. This is range B, this is range C, and this is range D, okay? These are the possible ranges of x, okay? Now what I have to figure out is how many values, okay? For how many values of x is this inequality greater than or equal to 0? Which means that I need to figure out if x is in this range, is the product of these three numbers positive or not? If x is in this range, is the product of these three numbers positive or not? If the x is in this range, is the product positive? If the x is in this range, is the product positive? Once I figure that out, that's when I get to know, okay, which are the pertinent ranges for my solution, okay? Once I have that, then I figure out how many values of x such that x is less than 5 satisfy this inequality, okay? And I want you to take a look at this slide in the PDF that I'm going to share with you, right? But this is exactly what I'm doing, okay? I'm doing all the processing over here, right? I'm taking each of these ranges, A, B, C, and D, and I'm taking some sample values, right? And then I'm figuring out each of these terms, are they positive or negative? Then I'm figuring out the expression, the entire expression of the product of these three numbers, are they positive? Is that positive or negative? When I do that, what I get is, and I want you to do that on your own, okay? When I do that, what I get is that applicable ranges are A and C, which means that x is greater than 2, this is a range and this is the pertinent range. And so these are the two possible ranges for x. Now the next thing that I have to do is I also have greater than or equal to sign. I have equal to sign as well in my inequality, which means that the pertinent my ranges are x is greater than or equal to 2, or -3 is less than or equal to x is less than or equal to -2, right? But this is not possible. Why? Because I have to go back to my expression x minus 2, right? X minus 2 is in the denominator, which means that x cannot be equal to 2. So this is where you have to apply the constraints. Okay, you have to look at the initial thing, and again, this is something which you should capture right up front when you're analyzing the question statement, that x minus 2, x cannot be equal to 2. This is a constraint that you should have recognized up front, okay, so that you can apply that later on. Now, because x is not equal to 2, which means that these are your possible ranges. Now, based on these ranges, you figure out, okay, how many values of x are less than 5, okay, and these are the 4, -3, -2, 3, and 4, okay, so 4 is the correct answer, okay. So overall, in this question, you had to first do simplification to bring it in the form that you can process. Then you had to do all of this processing. Now, again, one thing that I do want to tell all of you is that there can be, I used a very fundamental method to solve it, right? But you can use any method that you're comfortable with. You can use wavy line, you can use a wavy line method. You can simply follow certain, once you do understand all of this, you would also realize that alternate ranges, things are positive, sign changes in the alternate ranges, right? So again, those are inferences, those are corollaries that you can arrive at, right? But again, what I have shown is a very, very basic foundation method. Once you understand this, then you can see certain faster ways of doing this as well, so that you don't have to assume these sample numbers in the session, in the test environment, right? So again, processing can be done in different ways, but ultimately, once you, this is where a number of people make mistakes. They consider, either they don't consider equal to sign at all, they forget to consider this equal to sign, or they don't consider the constraints, which is why they may end up selecting the wrong answer. And that is why this question this question is a difficult question. The accuracy for this question on our platform is 40%, which means it is definitely a 700 level question. Okay, so I'm going to stop now because I do have a hard stop here. Again, I'm going to let me share the PDF with you over here so that you have it with you. And there are 2 more questions, so I do want you to solve those questions on your own once I share the PDF with you. Okay, here's the PDF. All right, then, good luck, everyone. And do let us know if you have any questions whatsoever. And write to me at payal@e-gmat.com if you have any questions whatsoever. All right, so good luck, and let me know how this session was. I would really appreciate if you could put in some comments and just let me know as to how this session was, because that really helps me. And on Friday, I'll be doing a similar session on creating error log for boldface questions in critical reasoning, so definitely join me there. Okay, so good luck and bye-bye.